the equation of the plane parallel to the two vectors 2, 0, 3 and vector 0, 1, 1 that is passing through the point 2, 0, negative 3. So what are we given here? Well, we're given a point on the plane. We have our point P naught, which is defined here as 2, 0, negative 3. And we also have two parallel vectors. So we have two vectors parallel to the plane. And let's label these vectors. We'll say vector number 1, we'll call this vector u. Vector u here is defined as 2, 0, 3. And we've got this vector v, 0, 1, 1. Now, what do we want? Well, we want to find the equation of the plane. So we want the plane. And we know, of course, that that's defined by the dot product of the vector p naught p with a vector normal to the plane. So the dot product of these two vectors should be 0. Now, we're missing one important feature here. We're missing the normal vector. So how can we use this given information to find a vector that's normal to the plane? Well, let's quickly recall the definition of the cross product. So let's recall. We know that the vector, say, u cross v, is normal to the plane containing those two vectors that make up the cross product, containing vector u and vector v. Now, wait a second. We already know from what's given that we have a plane containing these two vectors, u and v. So to find a vector that is normal to the plane, we simply need to take the cross product of the two vectors on the plane or parallel to the plane. So let's go ahead and do that. So we need to find the normal vector n, which here we'll define as u cross v. But is that an exclusive solution? No. You could also use v cross u. So make a fun little love note here because math is fun. We can also use vector n being defined as v cross u. Why? Because that's equal to minus u cross v. Woohoo! So pick your favorite and go with that. I'm going to use u cross v here. So here we go. We have the normal vector n, and to define the cross product, I'm going to put these vectors into our 3 by 3 determinant. So the first row is the standard unit vectors I hat, j hat, k hat. The second row is vector u. So we have 2, 0, 3. And our third row is 0, 1, 1. So by the cross product, we are left with 0 times 1 is 0, minus 1 times 3 is 3, I hat, minus 2 times 1 is 2, minus 0 times 3 is 0, j hat, plus 2 times 1 is 2, minus 0 times 0 is 0. So here we go. We can say that therefore vector n has the components negative 3i hat minus 2j hat plus 2k hat. And if you used the cross product defined as v cross u, you'll have the same answer with different signs. And we're officially ready now to go ahead and find the plane. So we have our normal vector, and we have our given point. So let's take this point here. We've got point P naught. Your x naught, y naught, z naught is 2, 0, negative 3. And now we can give ourselves plenty of room. So here we go. We know by definition that the plane is defined by the dot product of the vector p naught p. So x minus x naught, y minus y naught, z minus z naught. And this is dotted with the normal vector with the components a, b, c. And because these vectors are normal, by definition of the dot product, their product is 0. So let's plug in what we have. We have x minus 2, y minus 0, z minus a minus 3, and we dot this with the normal vector. Negative 3, negative 2, positive 2 is equal to 0. And we really don't need this minus 0 in the first part. We know that that will just leave us with y. Now, by definition of the dot product, we'll have minus 3 multiplied by x minus 2, minus 2 times y, plus 2 times z plus 3 is equal to 0. And we're ready to simplify. We'll distribute these coefficients through, and we'll group up our like terms. So we have minus 3x plus 6. We have minus 2y plus 2z plus 6 is equal to 0. And we have two constant terms we can combine. 6 plus 6 gives us 12, leaving us with minus 3x minus 2y plus 2z is equal to negative 12. And so this is our beautiful final answer. Now, I want you to keep in mind that if we divide both sides here by negative 1, an equivalent form of our answer could be defined positive 3x plus 2y minus 2z is equal to 12. So, of course, they're both the same, right? So whichever one you choose, as long as your algebra is accurate and consistent, both answers are perfect.